Okay, so we are live now.
Cool.
Well, some people are probably joining. Should join a little bit later. Yeah. Let's see whether we have any big topics. I mean, of course, there will be like a new release. I hope I can manage it tomorrow. I'm not sure though.
We have pull requests then?
We can go to the pull requests then, yes. Why? Is there a pull request from you? I don't know.
Only 3.
Oh, that's not that much. Only 3, yeah, let's see. But they are relatively small, right?
Yeah. I tried to...
Oh, I have to get used to this interface. It's really confusing. I don't know. Labels are round and stuff like that. It's like, it's too round, everything.
You mean GitHub is changed?
Yeah. Yeah, then, yeah, I don't know what we can do. I mean, I don't have any complaints for that first pull request. Yeah, so did that like, that's probably a result, Pedro, from your from the bug that you noticed, right, with the reorientation?
Yeah, so I found out my problem. I was trusting too much on the code to reorient my elements properly, and
Okay.
I never bothered. I never bothered like figuring out exactly how to orient them. I just put like the nodes in the right anti-clockwise order, but I never cared if they were pointing inside or outside. And so the code that reorients the surface quadrilaterals, it's relatively easy for it to give a false negative. So to not reorient an element that needs reorientation.
Okay.
Because it does 4 tests for a quadrilateral. It computes the volume of 4 tetrahedra defined by 3 nodes on the quadrilateral and 1 node inside the domain, like a reference node inside the domain. And so if the quadrilateral is like a little bit twisted or something, it's easy for one of those 4 tests to fail. So and then the element would not get reoriented, even if 3 other tests were saying, yes, you should reorient this element.
Okay. So a couple of regression tests failed, but it's only the on error case. Okay.
Yeah, it was only that one, and I think it's because that mesh is not very good. It's like this structured C grid, and it's
this very
off.
coarse one.
Yeah.
Okay.
And so you actually see there that if you look at the output, now in the output I actually print the number of reorientations. And so right now there's a message there saying that 18 hexahedra are distorted. And so, yeah, before those hexahedra would be reoriented under the criteria that was used to reorient the volume elements, but now they're not. They're just identified as distorted, and we cannot figure out for sure if the element is not rotated, or if it's actually twisted, because of the tests we do.
Yeah. Okay.
The test. So if you give, yeah, because the change orientation functions that we have on the primal elements, they can only correct for if the element is kind of rotated. But if you actually twist the elements, so if you rotate the top with respect to the base, for example, it will not be able to correct that.
But
Yeah.
shouldn't the mesh generator take care of that actually?
Oh yeah, of course. That's why. Yeah, ideally meshes that are produced by some generator are going to be like all pointing in a good direction.
Okay, maybe if you generate it by hand or something like that, then you can encounter the problem. Yeah, but it's good. Okay. Yeah, but does it now also solve the problem that you had? That
yeah.
Okay.
Yeah.
That means, yeah, but does it still change a little bit the residual or something like that if you write it out with dev, the mesh?
If I do what? Sorry.
If you had the problem that if you just don't do any deformation, but dev just writes out a mesh, that it gives like a little bit different.
No, it's fine. It's fine now. It's fine.
Okay, good.
Yeah, it was just because of that. Yeah, and if the criteria for the volume elements, the criteria was a bit different than the quadrilateral. For the volume elements, we do multiple tests, and if any of the tests fail, we reorient the element. And so basically, SU2 Dev was SU2 Dev was on the first pass. It was reorienting, and this would be correct. But then when SU2 CFD would read it again, because the element was slightly twisted, it would reorient it again, which would put it back in the wrong position. So I also made that a bit more. I also made that test for the volume elements a bit more robust. Yeah. So now it only reorients if it can tell for sure that the element is definitely rotated, and if not, it reports it just as twisted. So at least you get some indication of what might be happening.
Yeah, sounds like a reasonable change, definitely. Yeah. It's always good if you encounter a problem that you make it not only go away, but also improve the code.
Yeah, hopefully it will.
And what was the problem with the other pull request there? Well, not really a problem, right? It's just in performance.
Yeah, just a small improvement that I saw we could do.
Okay, yeah, that means they can definitely go in. Yeah, it also doesn't change anything.
I had it in the vectorization work, but actually since to try and make that pull request lighter, I cherry picked some of those smaller changes.
Okay, that sounds good. Yeah, we can definitely improve that. I mean, I will try to get the release done next week on the 1st. So, yeah, and then the other one that you have open there is the stabilization. That's really cool, actually. So
yeah, it's actually more stabilization than acceleration.
yeah, okay,
So
okay.
it's really hard for the joint to just diverge now.
Yeah, did you do some
even
tests also with the lower residual or something like that of the primal, or?
Yeah, but that's the thing. Like, if you're running an optimization and you get to some case that in the middle of the optimization doesn't converge so well, what can you do in the middle of the optimization?
Yeah, of course. Yeah, cool. Yeah, I have to test that. I have not tried it yet. But it sounds really interesting.
Always said he was gonna have a look as well.
Yeah, well, everything that helps stabilizing it is definitely good. But you didn't do any particular tests. Oh, we have some feedback here.
Any what? Sorry.
Or we have some feedback from you.
From me?
No, from Ola. He's not. Okay. Now it's better. No, I was just asking whether you did some tests for. Probably you did that, but do you have some charts or something like that, or I don't know, or can you say like, for example, a case that where it,
the thing I can tell you is that I'm running some optimizations right now, and some of them were like exploding, like the and now they're not.
So was it because the primal was not converged very well then?
Yeah, mostly because of that.
Okay.
On some intermediate designs, it would not converge very well, or it would go to some limit cycle kind of convergence, and yeah, and with this the adjoint just copes better.
Cool. Yeah, I will definitely check that out. It's it looks a lot like the recursive projection, right? It's a similar approach.
Yeah. The construction of this window of previous iterates, that's the common basis of this IQN ILS method and the recursive projection stuff. And the main difference is that that in the recursive projection method you're actually using Jacobi, so derivatives extracted from AD, and this IQN ILS method is a quasi-Newton method that more directly works on the past iterates with this least squares approximation. I read over Pedro's pull request, and I think it's almost directly good to go. But yeah, I will just do the official review on GitHub tomorrow. But I think it's directly good to go. I think it doesn't need any changes or something.
And yeah, I started reading the. Oops, sorry.
I just said, and I learned about tiling. Wasn't aware of that. And yeah, concerning my question on GitHub, that was just I didn't read so carefully the first time, and what you're using is the solver from the symmetric metrics from the native symmetric metrics implementation in SU2 to invert it. And
Yeah.
I thought
So
the
the
module because I missed
decision
some QR stuff and and
the decision there is the decision there was if I wanted to do a QR factorization, it would not be easy to find something that would work with MPI like out of the box. And
Okay.
even if I wanted to use Eigen doesn't know about MPI, so you'd need to copy all the data to the master node. And with the normal equations, you can make it parallel very, very efficient.
I see. Copying the data or doing this all together and then copying the data to the eigen data structures is what I did first, and I'm quite lucky that I now have a proposal in this pull request how to improve that stuff that I implemented, or I will just directly use your stuff to assemble this VK matrices
Yeah, cool. So the idea was to make this kind of a family of methods, right? So that we can, if they all can have this can have kind of the same interface, then we can have different methods of stabilizing or accelerating the adjoint.
Yeah, sure. Great. Yeah, that's what I thought too. Yeah. So great.
Yeah, looks very good. I definitely have to check that out. Try it on a couple of cases. But can that also be used for not just for the adjoint, but also for like some other primal computations?
So this was the method that I was using for FSI, for the FSI coupling. I've not implemented it for the FSI coupling yet, but I think this would work for that as well. And yeah, I don't know about. I made some of the auxiliary routines having in mind maybe targeting the direct solvers, but I've not tested if it helps with the direct problem or not.
Okay. No, looks good. Very cool. Definitely thanks for that contribution.
No problem. I was just solving my own problems.
Yeah, I mean, this is how it goes, right? And thanks that you make it available to others as well. Well, I think we can definitely have that in for next week. I don't see a problem there.
Yep, I think so too, yeah.
Cool. So what else do we have? I mean, yeah, we can also merge the geometry unit tests in soon. No, looks okay. That's it for the pull requests, I would say. Okay.
Yeah, there's the radial equilibrium one, but we're still waiting on some feedback about dividing by zero.
Okay, yeah, it's there for a relatively long time already. Well, 26 days. It's still okay. Yeah, okay, but all the others are drafts or work in progress. Yeah.
Yeah.
Okay, then we have some time for any other stuff. If there are some questions or something like that, I don't know.
Hi all, I'm Arturo Cajal.
Hi, Arturo.
Working on transitional models. Hi all. I have some questions now. Basically, I'm trying to make run the test case that is in SU2 with the BC model, but I'm struggling to make it work. Like it runs, but after like 2400 iterations, it just gives me that it was solved by initial guess, and I don't know why is that the case. I'm not sure if you had the same case when running the test case. And then, well, that'll be my first question, like if I can get some feedback. I'm using the config file provided. The grid file is not provided in this version, but I'm just using the previous one, assuming that nothing changed on the mesh file. The boundaries and the markers are okay. Yeah, so that would be kind of my first question. If you have similar.
So what case exactly was that? I heard BC, so the transition model case?
Yeah, it's the transitional model, the T3A case that is given in the test cases. So yeah, I'm getting that problem. Also, the config file needed to be updated, so I don't know how to submit that update. It's just changing the options. Some of them were a little bit outdated.
Oh, this case is not in the regression tests, apparently, then.
Yeah, it's probably one of those examples that is not actually a test.
Okay.
I mean, the whole transition implementation looks like a big work in progress. So if you looked at it, you see that it has like a lot of debug statements still.
Yeah, but he's using the BC model, so the algebraic one.
Yeah,
which
exactly.
is just a modification of the SA model.
Smaller numbers, yeah.
Ah, okay.
Yeah. And then, well, yeah, let's just first address this, or how can
So it's in transition. Ah, okay,
yeah,
the E387 alpha.
No, that's the Epler airflow. It's the T3 case, the flat plate.
E3A, okay.
Yeah.
So the thing you're getting with the solved on first guess, that's a message from the linear solvers, and it's basically if the norm of the residual is very low when you enter the linear solver, the linear solver actually doesn't do any iterations. So what ends up happening is that for that iteration of the solver, of the turbulent solver, you will get an explicit update, basically.
Okay.
As for why that happens, I don't know.
Yeah.
Okay. Are the residuals low? So it's a flat plate. So does it converge like to very low residual? The case?
Yeah. Yeah. It's minus.
Yeah.
15. Yeah. Something like
15.
That. Yeah.
I think 15 is definitely in the range where you can start getting that message.
All right. Okay. Yeah, I'm gonna look into it then with more detail.
I mean, as long as you get a reduction like of several orders of magnitude of the residual, then I would say it's fine.
All right.
I mean, it's quite natural that it happens then.
Yeah. Okay, makes sense. And
Yeah,
then,
minus 15 is basically the precision of a double.
yeah,
So
double, yeah. I'm basically just running the given the config file I just updated, and I just
If you look at the tutorials, there is a transitional flat plate, and this is exactly the same case. So in case you want to see like how an updated config file looks like.
yeah, and I got the grid file also from there. So yeah, okay, sounds good.
Okay, perfect.
And then also I'm implementing a new model, pretty much similar to what Langtrementer is. So I'm about to submit my pull request. However, I would like to make some questions first before submitting. The transition model, the transitional models, like the folder within the SU2 CFD folder, would be included as a new folder next to all of them, or it needs to be included inside the turbulence solver folder, if that makes sense.
so now the way we organized, is there a separate one for transition? So
No, it's just the
source,
file,
new
because it's just a LM, which is just one model. But now I'm gonna put more models. So basically, I guess would be better if we add a new folder. But just the small question is like for
Yeah,
organization, inside
I think
turbulence
make
or next to it.
make a folder for transition and move everything inside that.
Okay, but
Move both your new models and the old ones.
the LM. Okay, but that would be inside the turbulence because it's part of turbulence, or just next to the rest of them, if that makes sense.
Just next to turbulence, I would say. Make another
Alright.
folder. Make a folder under numerics called transition and put everything there.
All right, and then for the SSD model implemented, the turbulence model, when allocating the solvers in the driver, I'm not sure why there's a pre-process for the main flow solver, and then we perform a post-processing for the turbulence solver. But back again, a pre-processing is performed for the main flow solver. That's in the C solver factory CPP file.
That depends on how the yeah. Sorry, go ahead.
So usually you need the pre-processing of the primal solver to get the gradients, because the gradients are then used in the post-processing of the turbulent solver to compute viscosity.
Yes. But then after that, a pre-processing of the flow is performed. Again, I'm not sure why is that happens.
Because the turbulent kinetic energy occurs in some of the computation for the primitive variables, for the pressure.
Yeah.
That's true. Okay.
Yeah.
Needs to be updated again. Okay. Makes sense.
Yeah. This is why you have this strange dependency there.
Yeah, makes sense.
Yeah, they're a bit tightly coupled.
Yeah, this makes sense. And finally, I'm a little bit confused on how to treat some terms when computing the implicit calculations of that same model, the SST. Like for instance, the production term when computing the flux of the first equation with respect of the turbulent kinetic energy, for instance, the production term, isn't it a function of the turbulent kinetic energy as well, and should be derived? If that makes sense.
So can you point us to a particular function of the code or a line that we can look at?
Yeah, it's in the source, in the turbulent source.
Yeah.
Turbulent sources.
Or you can share your screen for the benefit of the YouTube viewers.
All right, that'll be tricky right now because I'm not I'm in my phone making the phone call, and my desktop doesn't.
All right. Okay.
Mic,
so C source piecewise turbulence SST compute residual.
Yeah, and the implicit calculations. The production term PK. So for instance, the Jacobian I00, that's the derivative of the first flux with respect of the first equation, of the first variable, the first solution. So basically, the source term of the kinetic energy with respect of the kinetic energy, right? So the production term has P has is function of the turbulent kinetic energy. However, when computing the derivative, it's not here. It's neglected, I would say, but I don't understand why.
So you're saying we compute residual 1 or residual 0?
Give me a second. In the Jacobians.
Yeah.
When computing the implicit part. So for the first equation of the
for which
SST
index?
model.
0, 0, 0, 1?
0, 0, yeah. 0, 0.
0, 0. Yeah.
That would be the derivative of the production term and the dissipation term, right? With respect of K. So the production term is neglected. The derivative of the production term, which is function of the turbulent kinetic energy, is not computed. I'm not sure why the production is treated like as a constant, if that makes sense.
Okay, so I think I see what you mean. We have PK.
I think that we
so there's two explanations.
Okay.
Explanation number 1, it was an oversight. Explanation number 2, maybe omitting that term makes the Jacobian better conditions. When you assemble all the terms, maybe it makes things better conditions. That's the second explanation.
Okay.
But then you know of this this thing that people do a lot when they do scalar transport. They build the matrix in a way that respects the Scarborough criteria.
Okay, I'm gonna look into that. I don't know about it.
So you would want this to be diagonally dominant and not to have negative coefficients. And because the Jacobian of the source term goes only to the diagonal, you don't want to upset the diagonal. So I don't know, but it's a 50-50. So there's also a chance that it's a bug.
Okay. But then also kind of same idea applies to the cross diffusion term, right? Which would be the coefficient of the Jacobian, the 1, 1. So the cross diffusion term is also a function of omega, for instance, which is the variable that we're deriving with respect of now. But all that term seems to be taken as a constant. So it's not computed the derivative.
Yeah.
And similar thing with the production term. So for this second equation of omega, we have production, dissipation, and cross diffusion, and the only one that is taken in account is the dissipation for the derivative. Similar thing happens to the first equation for the turbulent kinetic energy. We have only production and dissipation, and the derivatives that are taken in account are just the ones from the dissipation. So it might be something along those lines that you just
you can have a look at pull request 491. There was already a discussion on these terms.
Okay. Yeah, I'm wondering because I have similar terms in my implementation, and as mentioned in the conference, it's pretty much the implementation is pretty much done, but I'm just having this divergence that I don't get, and most likely it's coming from these implicit part calculations because the rest of it looks correct to me. So I'm gonna dig more into this and submit the pull request as soon as possible, hopefully this afternoon, and then probably start a more formal discussion in the GitHub forum.
Yeah, that sounds good.
Thank you.
Okay. Yeah, I think that pull requests should probably help because Clark Peterson was already dealing with that somehow.
Okay. 491, right?
Yeah, you know how to access merge pull requests?
Yeah.
Okay.
Thank you.
Okay. Are there any other questions?
Hello. Yeah, I have one. Well, a couple of
Go
questions.
ahead.
First of all, just to make sure, the gradients for the turbulence variables are computed with TSL approximation, right?
With what information? Sorry.
For the turbulent gradients are computed with TSL.
TS what?
Thin
It's
shear
quite
layer.
likely.
The thin shear layer approximation, yes.
I'm not 100% sure, to be honest.
I don't know what that is.
That's the same technique that is used for all the other approximations too. So it's quite likely that also TSL is used there. Yeah, because for the Jacobians of the fluxes for the flow solver, this assumption is also used.
Okay. Yeah, my second question is maybe it has the same answer as for Arturo. On the spiral Armada's turbulence model, we do not compute the derivative of the diffusion term. So maybe it's, as Pedro said, 50-50. It's omitted because it's then the Jacobian is better imposed over. So I don't know.
I mean, after what Tim said, that this stuff was revised by Clark, I would put it no longer at a 50-50 because I think Clark pretty much knows what he's doing. So yeah, it might be because of stability. It's very common for source terms. You only add it to the diagonal of the matrix if it's going to help with the condition of the matrix. If it has potential to make it worse, then you just don't add it because the final result will still be the same.
Sorry to interrupt.
The
procedure would be try and error then, Pedro? Like each
Sorry,
term, just
what?
adding, the procedure would be then try and error, like for those terms then, for the implicit calculations, like just compute all of them and then start like taking one of them at a time and just see if that makes the code more stable.
No, I think usually what the systematic or the kind of the cookbook recipe is, if it's going to reduce the magnitude of what you have in the diagonal of the matrix, you don't put it there.
Okay.
If it's going in the other, off the top of my head, I don't know if the diagonal is usually positive or negative, but you get the idea. It's just based on the sign of the derivative.
Yeah, thank you. The last questions in the negative spiral Armada's variation, we do not compute the modified vorticity, which is, for me at least, one of the main reasons for one of the main characteristics of this variation. So, is there any reason for that?
Okay, sources, SA
Yeah,
negative.
it's in, yeah. Sources turbulent, sources, numerics, turbulent sources, CPP, and then down on C sources pairwise turbulence negative.
Is it something that it's commented out, or?
No, it's not implemented.
Okay. Well, I mean, there's that. There's an issue that Tom opened on GitHub after you asked a similar question some meetings ago.
Mm-hmm.
I think you can add this to that discussion.
Okay.
If there's like just to make sure that that we are implementing things by the book, and that this is not some obscure variant of SA negative.
Mm-hmm.
Yeah, just add it to the issue 992.
Yeah. If you have some reference from that TMR website or something, just put everything there.
Okay, thank you.
Okay. That's all from questions. If so, I mean, I just have like a small proposal that I need some opinions on. So the question is whether it would make sense to have the output always dimensional. I don't know what your opinion would be on that, because for a lot of things, it's quite complicated to find the proper factor that you have to multiply it with. So maybe it would be easier to just output it dimensional.
The output should be what, sorry?
Dimensional. Even though you compute non-dimensional, maybe it would make sense that the output is dimensional and always dimensional.
How is that going to work with the restarts?
That is a good question, actually.
Because right now, I think if you restart and you change the way you have the way you dimensionalize, it's going to cause problems, no?
Yeah, probably. I mean, but even if it's dimensionless, you still can only use it with the same config file, which is the same like non-dimensionalization factors. So you could just divide it by the so you can make it non-dimensional again.
Yeah.
Because I just think that for some things it's complicated to make it dimensional again, and it would be much easier if the code just does it for you.
I don't have strong feelings. I usually run the code dimensional, so it wouldn't make a difference to me.
Yeah, okay. Because I'm thinking for the output, if all is customizable and stuff like that, you can define your own functions and stuff like that. It's quite complicated, I think, to get the proper dimensional value out of it.
Oh, right. For when you compute something with the output quantities.
Yeah, exactly. Right. You have an arbitrary function, and then you want to have the dimensional value of that. You have to look like how all of the single values are non-dimensionalized, stuff like that. And then I think it's very complicated. So it would be much easier if all the output values, all the output quantities are already dimensional. But I don't know whether there is some advantage of having it in a non-dimensional form, the output, but I don't see a big advantage. But
I don't know, unless you're trying to compare things at like different flow conditions and you want to look at it kind of in a comparable way.
Well, maybe there should be some kind of option to have the output dimensional or non-dimensional. That would be another option, of course, another way.
Yeah.
I'm just thinking that it would make like a lot of things a little bit easier.
Yeah, but for the expressions, you don't care about what is the dimensional factor, right?
Yeah, that's the thing, right? So you can just define arbitrary functions, but only of the non-dimensional versions. So if you want to have the dimensional one, then you have to manually like
insert your factor there.
Yeah.
Yeah, but I think that would be the responsibility of who writes the function, right?
Yeah, of course.
Yeah, I don't know. If it's easy to make it an option, then make it an option.
Yeah, I don't think that is that well. I don't know. Also, the way how it's non-dimensionalized at the moment is also not the best.
Why?
So at some point, yeah, well, it's in this non-dimensionalization routine, and it's
yes.
called upon constructing the solver. Yeah, it should be maybe in a more like central place to have dimensional values for all of the different variables that you might have. And it's also a little bit confusing, and I don't know. There probably is a better way of doing it, but it's just hard to get in the output like all the different factors for the non-dimensionalization. It's quite a lot of manual work.
Is it something that you can add when you mark something for output? So right now, when you add a variable for output, you specify like the group and the description. Could you put the dimensionalization factor as one of those things, and the output would just cache that value and apply it whenever it needs?
Sometimes it depends on how that value actually is computed, right? I mean, you only have the non-dimensional factors for like very few variables, and then it just depends.
And some of them are derived from that.
Yeah. But that would be maybe one option, yes. Yeah, I thought about something like that. Yeah, yeah.
Yeah, I don't like that routine very much. It sets things in the config. I don't like when things set other things in the config.
Oh yeah, at some point we have to get rid of all that stuff. That's really, it's not good. That's really not good. So the best way would be to have it like somewhere in the config really, or some extra module or class.
Exactly. I was waiting for you to say that word.
Yeah, it is like that, right? You just an extra structure that deals with the physical properties, with the physical interpretation and non-dimensionalization. That would be really.
Yeah.
And then you can just ask it, okay, I want to have for time of whatever the non-dimensionalization factor, and then yeah, but maybe that's just a dream. At least for now. Someone else has an opinion on that? Doesn't sound like it. Good. Well, then I will think about like having it as an option or something like that. Okay, are there any other topics? Anyone else has a question or?
Have you have you looked at what the vectorization looks like?
What do you mean?
The code, if it still looks readable.
You mean what I wrote in that mail, or what do you mean?
No. My draft pull request, the SIMD framework.
Oh, yes, that's also something we have to deal with. Yeah, that's. I haven't looked into that in detail, but I already thought about something like that, since it's very much related to the hybrid parallelization. But are you using the OpenMP pragmas, right? Yeah. Okay.
Yeah. So I have like this SIMD type and the operations on the SIMD type right now. The only I use that pragma to kind of nudge the compiler into vectorizing, but that type might eventually become something more efficient and specialized for particular types. But I mean like the new numerics kind of idea where you don't set anything into the numerics just read the data that they need to read, and I think it looks better. I think the code looks more readable this way.
I definitely have to check that also out. Yeah. I have not looked into that in detail, but I think that's a good idea actually. Have you like made some performance tests already using the SIMD things?
Yeah. So right now it only runs for Euler and Rho.
Yeah. Okay.
And it's I mean I've only tested the Onera M6 case yet, and it's about 20% faster. But
Okay.
you know there's still a lot to optimize.
Yeah, but that's already something that's.
Yeah, it's still a bit compiler dependent. For example, so if I compile the code with GCC 7.5, like the vectorization is better than what we have at O2 optimization. But if I go to GCC 10, it's actually slower at O2, and then it becomes faster again at O3. So it's not
Okay.
it's not consistent with the compiler.
Well, as long as it's not like worse than without.
No, I don't think it will be. No.
So is it enabled by default? No. Or how do you do that?
Yeah, so I haven't decided on that part yet, because I will not rewrite all the schemes that we have right away, because that would be a lot of work. So maybe I will have some schemes that the ones that can be vectorized, they will be vectorized automatically, and the ones that, or maybe I could have an option with row underscore vectorized. I don't know.
Yeah, but does it make sense to have both then, really?
I kind of need to, at least for the moment, because of the boundaries.
Okay.
So the numerics themselves, they don't need to be. They can actually be compiled with either the SIMD type or with a scalar type, and they work like perfectly fine. You just need to switch one type or two types, and you get either scalar or vectorized. But yeah, the boundaries require the boundaries require scalar, probably.
Yeah, but can you maybe just instantiate like one for the boundary and then?
Yeah, I can. It's just that the compute residual method is different, right? Because these numerics don't have the same parent. They don't have the same parent as the other numerics. Because it doesn't make sense. Like this numerics don't have like almost no fields, no member variables. It's a very lightweight class that it's basically just functions.
Mm-hmm. Yeah. Okay. Yeah. Okay. Maybe at some point we find a solution for that, but let's see. Yeah, but that's very cool. So what is left? What do you want to do still there? Is there something major?
Yeah, viscous. I need to implement the viscous part
Okay.
to at least have like a complete example for RANs.
Yeah. Okay.
So I'm doing the thing I like the least, which is copying code.
But it's the easiest part.
No, it's not easy because I end up always rewriting something. You always see something that could be a bit better, and then you rewrite, and then you make a bug, and then.
Yeah, but then you have to copy it back to the original plan.
Yeah.
Yeah, very cool. Really looking forward to that. Yeah, I'm definitely going to test that. Okay, the other pull requests are already in there, right? Yeah, this is why. Yeah, okay. Yeah, very cool. You are very busy, man.
Yeah, and I'm trying to do a PhD as well.
Yeah, but can you use that stuff for your PhD? Do you?
Yes, of course. For thesis.
Yeah, okay. I mean, that's not always the case. So I'm just asking.
Oh yeah, no, I'll put it there. I don't care if they like it or not. Like it's.
Yeah, you definitely should. I mean,
it's what the funding is paying for, so it's gonna go in the thesis.
Yeah. Okay. Yeah. Very cool. Okay. I mean, we are at 5. I mean, if there are no further questions or topics or whatever, then in theory we can stop here.
Yeah, sounds good.
Yeah, so we can definitely merge in the 3 or 4 pull requests that are still open, and then new release next Wednesday.
Sounds good.
All right.
Okay, then we talk to each other next week.
Yep. See you next week.
See you next week.
Thank you.
Yeah. Bye-bye.
Bye.
Bye-bye.
Thank you. Bye.